Guys, we are back with our regular class structure and the subject is mining geology, and this is the part 2 video. And so far what we had seen in the part 1 video is what is underground mining, why we should go for underground mining, and what are the types. In the types we had covered at the first two types. One is the primitive method of mining, that is the rat hole mining. Then the next one is when the formation is horizontal and thick. The method we can use for mining is the room and pillar method. And this video I will try to cover the longwall mining method and sublevel stoping method and shrinkage stoping method. So let us see what is longwall mining method. In our previous video we had mentioned that the thick horizontal rock or ore body can be mined using room and pillar method. In this case we have a horizontal rock formation, but it is thin, that is the thickness can be in the range of say 0.6 to 6 meter thick. So this sort of lesser thickness ore deposits can be mined using the long wall mining method. So actually what it is, let us see. Long wall mining is an underground coal extraction method where a continuous wall of coal is mined in a single slice. So here we are having a horizontal formation with a lesser thickness, and this can be sliced out or extracted out continuously. Okay, and it is characterized by high mechanization and efficiency, particularly suits for flat lying coal seams. So when you have flat lying rocks, we can go for this method, which is highly mechanized, and we can have a good efficiency for this type of mining. Okay, so what are the pros and cons? So the best advantage of this is it has a very high recovery rate, that is up to 80% and above. As it is continuously slicing, there is no any external support. And in our previous class we had discussed about the room and pillar, where we are keeping the pillars for the support. In this case we are not having any sort of supports as a mineral deposit here. So the recovery is comparatively high, that is more than 80%. Then how the support is taken, right? So that is the support is enhanced safety with the hydraulic roof support. So during mining only they are using some sort of hydraulic supports for the mines to be stable. So that is the second one. Third, we have advantage, that is continuous and automated operation, that is the mechanization, highly mechanization. So when it is continuous and horizontal, we can go for fully automated, very less labor required, right? So that is the fourth advantage. And the last one is it can provide up to large scale production capacity. As it is completely mechanized, you can go for large scale and a larger amount of production. So these are the advantages of the long wall mining method. The first is high recovery rate. The second is enhanced safety with hydraulic roof. The third is continuous and automated operation. As we are going automated, the labor required is low. And lastly, it is completely automated, so we can go for a larger production capacity. So these are the advantages. The disadvantages are subsurface subsidence. The very first disadvantage. In the room and pillar method, we are keeping some sort of support which is called a pillar. So the subsidence can be comparatively less. Here, when we are working, we are having hydraulic roof support, but after the working is done, that support will be removed, right? So there is a subsidence. So this is the very first disadvantage. Then we have high initial capital cost. As we are using so many machines, we have to invest a lot during the initial stage of the mining. But when the mine started, you can maintain the cost economy by high production rate. But it is actually highly initial capital cost. Okay. The third point is it has geological constraint. If you have a steeply dipping rock type, we cannot go for this sort of long wall mining. And if there is any sort of structures like fault and fold, there will be the structure may not be continuous, right? So we have a geological constraint in this method. Then we have backfilling cost. If the place should not be subsided above that, then we have to do some sort of backfilling, which is quite obviously expensive. So it is a disadvantage. The last one is in the room and pillar also we have mentioned this, that is the production of dust and gas management challenges. When you are working in the underground and the space is comparatively less, there will be a larger area of gas and dust production, and as the machines are working there, there will be higher dust production there. So that will be some sort of disadvantage during working. So these are the advantages as well as disadvantages of this method. Okay. Then the next one is the sub-level stoping. As you know, stoping and sublevel terms from the mining geology terms. Let me tell you once again. The stoping is the way of removing the ore body. That is called the stoping. Whereas sublevel is or level is a kind of tunnel that should be parallel to the strike of the ore body. So where comes the strike? The sublevel stoping method is used for a inclined thick ore body with a strong country rock. So when the rock is inclined, there will be a strike, right? So the terms level comes when there is a tunnel that is parallel to the ore body, and here the tunnel will be starting from the shaft to the ore body. So that is called a level, right? If it is on the surface, we is called as tunnel, but here the level opens one side in the shaft and the other side to the ore body. So this was the sublevel stoping term meaning. Sublevel stoping is preferable for the inclined thick and ore body with a strong country rock. Okay, the ore is extracted by drilling and blasting from multi sublevel developed at a regular vertical interval within the ore body, and the broken ore fall to the bottom level where it is collected and hauled out. This method can be highly mechanized, and it is often backfilled after ore extraction to provide ground support. So here also you need to backfill it. Here also you can go for highly mechanization as you have a stronger competent country rock. The mechanization is not a big deal here, right? And this level is good for inclined ore body. Okay, so let us see what are the pros and cons. So the pros are, first point, high productive and mechanization. So the strong country rock we have, so we can go for higher machines, and the production rate is very high, right? And the high ore recovery, as we are removing completely the ore body without leaving any pillars, the recovery rate is high, right? And safe working condition, as the rocks are inclined and the country rock is so strong, the portion of working will be comparatively less, right, compared to the horizontal rocks here. And we have good ventilation and continuous operation, as the ore body is itself inclined. The movement of air is convenient, quite convenient instead of a horizontal portion, right? So here the ventilation will be comparatively good. The last point is adaptable for backfill, reduce surface waste. So when you are breaking the ore body in an inclined formation, there can be possibility that you are breaking the country rock as well. So you may not be needed to bring the country rock above, so you can keep the country rock there itself for the backfill, and also you can use it as a support for some extent. So these are the pros of the sublevel stoping. The first is high productive and mechanization. Then we have high recovery rate, safety conditions, safe working conditions. Then we have a good ventilation, as the ore body is inclined, movement of air is quite convenient, and adaptable for backfill of the broken rocks or the country rock. We do have cons, that is some disadvantages. We have, what are the disadvantages? Let us see. The first one is the high capital and development cost. Here also it comes that when it comes for automation and mechanization, there will be high cost required, right? So this point will be matched in all sort of mining when there is a high mechanization is available. Okay, so this is a common point, that is high capital and development cost. Then we have limited selectivity, as the rock is inclined, the workers have to work, or machine have to work in a particular region. If the machine crosses the line, what happens? There will be a breaking of the country rock that leads to the dilution. So this is the limited selectivity, that is the machine has to break at a particular level only. If it crosses the limit, it will be breaking the country rock, and that will dilute the ore body, right? So this is the second cons. The third one is that it has geological constraint once again here also, where you need a strong rock and a regular ore body. If it is not there, then we cannot go for sub-level stoping. So the main condition for the sub-level stoping is the country rock should be strong. Then we have a complex logistic for backfill and sequencing, as we have to backfill and we have to work. So moving the material here and there will be quite confusing and quite complex, right? So these are the cons. So this is what a short explanation about the sub-level stoping. Okay. And the last one for today's class is the shrinkage stopes. So this type of stoping, as I mentioned earlier, stoping is the removal of ore body, is adaptable where the rock is inclined and the thickness of the rock is comparatively less. In the previous case, we have a good thickness There also we have so many limitations. Here the thickness is itself less, but the main plus point is we have a strong country rock. So this method shoots for an inclined ore body with a comparatively less thickness and a strong country rock. So we can go for shrinkage stoping. The shrinkage stoping is an underground mining method used mainly for steeply dipping relatively narrow ore body with competent ore and wall rock. So then the next point is mining is carried out from the bottom upward in horizontal slices. So here what we are doing is, as the ore body is very thin, we have to start from the bottom and move towards the top, right? So this is how the mining is done, and most of the broken ore is left in the stope to support the wall and provide a working platform for miners with only a portion drawn off during mining to accommodate the swell of the blasted rock. Okay, so you can see here, so they have started from here. They will be breaking the country rock as well as the ore body, especially the ore body, and they will be keeping the ore body here itself, so they can use this as a wall support and they can move on further up. So this is how this method is done. So breaking is done on the ore body, and the ore body have to be kept there for a support as well as for the basement for the workers to work, and they are moving up, above and above. So this method, this is how this method is done. This is the shrinkage stoping. And when you are breaking and moving up, the recovery from the mine will be somewhere near 30 to 40. So the amount of recovery will be comparatively less. Okay, just like room and pillar. But the next thing, important point is that when the stope is completed, all remaining ore is removed. So when the ore body is broken down from bottom to top, they can go for removing the broken ore from the underground mine, and they can go for other processing and making a profit, right? So this is how shrinkage stoping is done. So we have to break the ore from bottom to top, then we have to remove the whole ore body later, right? So this is how the shrinkage stoping is done. So let us see the pros and cons. The very first advantage is that broken ore supports the stope walls. So when you are breaking the ore body itself acts as a support for the wall. So you may not need any sort of external or secondary supports. The second is that less needed of artificial ground support. So as the workers are moving up and up, you may not need any artificial support for the workers to stand. So you can use the ore body itself for standing there and act as a good ground for the workers to move up. Okay. Good for steep, narrow ore bodies. As it is mentioned earlier itself, the ore body is narrow and steeply dipping. This method is more suitable. And here the high recovery, as it is mentioned eventually, not at the initial stage, only at the final stage you can remove a lot high recovery, but initial stage the recovery rate will be somewhere near 30 to 40%. And good ventilation and working platform. So we are moving in inclined formation, so the ventilation is not a big problem here. In like just like a horizontal formation, there is more problem in the horizontal formation, but here ventilation is not a big deal. Okay, it is good ventilation and working platform. Then the cons are labor intensive, not easily mechanized. So in a previous heading, that is sub-level stoping, we can go for fully mechanized, right? So here the mechanization is not possible as the thickness of the ore is very less. And delayed revenue from ore tied up on the stope. As the ore are broken and kept as in the stope itself, so the revenue growth will be very late. Okay, that is delayed revenue from ore. Okay, then we have risk of dilution from the wall rock. As the ore body is along with the rock and sometimes breakage happen, there will be possibility of dilution of the ore body. Okay, and the difficult for ore and waste sorting. So when you are breaking the ore as well as the rock and kept as it is for the support, and when you are removing at the later stage, you have to separate the ore as well as waste, right? So that will be a difficult task, and this is not suitable for weak ore or wall rocks. So the rock should be competent as well as the ore should be strong as well as competent, right? Then the production rate is low. So these are the cons for this shrinkage stoping method. If you have any doubt, mention in the comment section. We'll try to explain. We'll just conclude the class from up to this. Thanks for watching. Have a great day.